Hey, good morning, everyone. Good morning, friends. Right. I hope I'm audible. My voice is clear. Right. So today we are going to start a new playlist. It's on convolutional neural networks, CNN. Right. So before we understand the topic of CNN, I'll quickly walk through our YouTube channel. So, friends, if you are joining for this particular session, no, for the first time, so we already have many playlists in different topics. We have it on NLP, natural language processing. We have a separate playlist. Then we also have a playlist on ANN, artificial neural networks. Okay. Then we have playlist on ML classification and regression, both. You see here. So this is for ML regression, and the other one is for ML classification. So if you are joining for the first time, okay, if this is your first time that you're going through the session, just go and watch previous sessions on different topics because all these different topics are the foundational concepts for the neural networks. Okay, so again, if you are from non-IT background, no worries. I have done a separate playlist on Python as well. So this particular playlist, short-term trainings in English, we have Python basics, okay, the Python fundamentals, followed by EDA, exploratory data analysis, and then we have it on data pre-processing. Data pre-processing, okay. And in this particular 30 days free short-term training, we also have two algorithms covered as part of AI, K-means and KNN. And then we also have a playlist on SQL, structured query language, and a business intelligence tool, it's Power BI. So, friends, if you are joining for the first time, okay, if you're not aware of our YouTube channel, okay, go and subscribe to our YouTube channel, Next Era Unitech, okay, where you get the amazing stuff, lot of videos that are emerging. Okay, so it might be related to AI, ML, okay, Python. We have beautiful sessions. In the same way, we are going to continue this way of approach for the next coming programs as well. Right? Yes. So, in this particular session, we are going to understand convolutional neural networks. So, before you understand convolutional neural network, you should have some basic knowledge on neural network because if you don't know what is a neural network, you can't understand CNN. No, no, friends, you cannot understand what exactly CNN does, right? So just go through the previous sessions. It's on ANN, artificial neural networks, and CNN is a type of neural network. Okay, so as part of this playlist, we are going to understand, uh, the architecture of CNN. Okay, on which type of data CNN is used, and we'll also understand each and every layer present in CNN. Somehow the architecture is seen. We'll have input layer, hidden layer, and output layer, but there is a small change with respect to CNN. We'll understand the architecture as well, and finally we'll come up with a project. Okay, we'll implement CNN on a Python project, a use case. Okay, and we'll understand how it is implemented in real world. Making sense? So this is our agenda. Okay, and we'll do it in a day by day. It's not done in one such particular session. So on each and every day, we'll be learning some part of the concept, then followed by the next day, right? So this will be continued till we complete a use case, but a project. I hope it's making sense. So without wasting our time, let us get started. So let us get introduced to CNNs first. Okay, what is CNN? On what type of data is generally CNN applied? Then we'll talk about the components of CNN. Okay, then we also have types under CNN, convolutional neural networks, and finally the applications. Okay, so this is our agenda. And moreover, friends, my sincere request, if you are joining for the first time, go and subscribe to our YouTube channel, because in future we are going to come up with some amazing stuff. Okay, we have planned different playlist. Okay, we have planned a number of playlists as part of next coming 1 2 months. So just go and subscribe to our channel, and moreover, you can also share across your connections, your friends, your relatives, whomever it might be. Ask them to learn these, trending topics, right? Yes. So again, one more thing: if you are not aware of ANN, you'll not understand CNN. So this is a continuation topic. Why? CNN is a type of neural network. It's a type of neural network, right? So you have to understand how a neural network is, trained, how it works. You should understand forward propagation, backward propagation, and the important activation functions like sigmoid, softmax, tanh, ReLU, leaky ReLU, ELU, everything. Each and every topic has been understood as part of ANN, right? So this ANN is available on our channel. Just go through the sessions before understanding CNN. If not, I'm sure that you'll not grab the concept of CNN. I hope it's making sense. So without no further delay, let us go and understand the foundations of CNN. Yes. Have you heard about computer vision? Yep. So we have many, know, uh, tasks like object detection, classification, image recognition, face recognition. Yes, all of these part of computer vision, right? So in computer vision, we have vision. What exactly do you mean by vision? The term vision refers to the ability of a machine, to interpret and understand the visual data. So whatever the data it visualizes, the visual data should be understood and it get interpreted by a machine, not by a human. Okay, from the real world. So this is a basic definition that I'll give to the word vision. Since I'm using a computer which is a mission, yes, like how we humans, perceive images and videos. In the same way, a machine should get the visual. I hope it's making sense, and just trying to explain the concept of vision over here. Now, let me talk about the image processing. Okay, so if you see under computer vision, we have many tasks like image classification, object detection, see, you are detecting each and every object, right? Then object classification, nothing but image classification. We have image segmentation, right? So in this way, we have lot of tasks for computer vision. But if you ask me, the basic topic under CNN, it's images. Yes, exactly. So, friends, what do you mean by an image? Can you define what is an image? Because, CNN, convolutional neural network, is built for unstructured data. It is images. In order to work on image, uh, we also have videos, right? A list of or a sequence of images. So in order to work on image data, we have CNNs, convolutional neural network. But What exactly is image? If that is a question you have in your mind, image is nothing but it's a collection of small dots. If you take any image, okay, so it's a collection of small dots which are called as pixels. Pixels. Okay, so which are arranged in a grid, nothing but a table. So within a table, if you are able to represent image as a number, which are nothing but pixels, that is an image, right? So this grid represents a table, friends, and each pixel holds a color information. So assume that this particular image has been represented here. Okay, so I'll take this image. So this image, this is an image, and I'm representing with numbers, nothing but pixels, right? So this particular pixels I'm going to represent, which is having the original information of image. See, so what are these numbers talking about? They are talking about the color information. Okay, whether it is white color or black color. Here, anyhow, I see only two different types of colors. We also have multiple different colors. So this is complete black, and this is white, and this is kind of gray, light gray. Yes, I can differentiate the colors. So this colors information is represented using pixels. That's an image, right? So again, the question comes, what is a pixel then? You know, pixels are the smallest components. They are the smallest units of an image. So if you take the entire image, if this is your image, okay, so you are trying to represent this image in the format of pixels, right? Yes. So these pixels, they are the smallest component of image. Each and every number represents a color information, whether it is white, black, or anything else, whatever it might be. Okay. So if an image has more number of pixels, then the resolution and the clarity for that image will be very high. Yes, depending on the pixel number, obviously the resolution, the clarity for the image will be high. So nowadays, everyone started, uh, just purchasing 4K TVs, right? So when you go back in the earlier days, how is the TV picture? It's not that the clarity or the resolution of the image, the video that used to play on the television, that used, there is no such kind of clarity, but nowadays, if you take a 4K TV, the clarity of the image is awesome, right? It's very superb because of the pixels. More number of pixels is generating, high resolution for the image or the video. And, you know, at the end, this is what going to provide more clarity for an image, right? So how exactly is uh, when you represent an image with pixels, obviously you are getting a table. Yes. A table has rows and columns. So this grid is similar to a table, right? So it has both rows and columns. So how many rows you have? Just get the number, assuming that I have 25 rows. Okay. And how many columns do you have? When you are representing with number of pixels, what is the number of rows and number of columns? So this will give you number of pixels. Am I right? Yes. So 25 cross 25 represents there are 25 rows and 25 columns. So obviously 25 square is 625, which represents there are 625 pixels in this image. I'm assuming, friends. Okay. I'll not count exactly. I don't want to waste our time. So I hope it's making sense. In this way, we can get the count of pixels in the image. Okay, depending on the size of the image, we can get the number of pixels. Making sense? Yes. Now we got some understanding with respect to images. Yes, if you take an image and if you are going to play a set of images one by one, it is going to form a video. Yes. So what is a video? Video is nothing but a collection of frames, a collection of images. So in order to learn CNN, first understand what is the purpose of learning CNN. Okay, so CNN is a type of neural network. Neural network is representing artificial neural network. A neural network is also named as artificial neural network. Both are same. Okay, so there is no difference between it. Either you call it as a neural network or artificial neural network, it represents C. So in ANN, one of the type is CNN, right? So this CNN, convolutional neural network, they are used to work on unstructured data images and videos. Why? Why on images and no videos? Why cannot I use a traditional ANN neural network on unstructured data, text and images? Images and videos. There is a drawback of using ANNs on the unstructured data images. What exactly is it? We'll understand. But hope you got what exactly is CNN now. And we also understood what is an image. Image is nothing but a collection of pixels, right? And these pixels are the smallest component of the image. And how can you get the number of pixels? Multiply the rows and the columns of the image, you get the number of pixels. And let us talk about the types of images that we have. We understood what is an image. Okay. We also understood the purpose of learning CNN. Now let me go and explain, the types of images. So if you see here, there are two types of images, friends. Images are broadly classified into two types. I don't mean to say there are other types. There are also other types, but we generally use these two types of images. One is grayscale image, and the other one is RGB image. What is the other one? RGB, where R stands for red, G stands for green, B stands for blue. Now, I hope you got the types of images. Okay. Now let me explain what is this grayscale image and what is this RGB image. Nothing but color image. So grayscale image is an image in which each pixel, the pixel that you are going to have in the image, the value for this pixel, they lie between only 0 to 255. So, Akhil, what do you mean? I mean to say that beyond this range, you cannot have the value for the pixel. Okay, you cannot have a negative value for a pixel, and you cannot also have a value which is greater than 255 under a grayscale image. Okay, so what exactly this range represents? What does 0 represents in a grayscale image? 0 represents black color. Okay, that is the reason why in the previous image, I'll go back. Okay, after some time, I'll go back. I'll show you. Wherever we have 0 in a grayscale image, it is representing black color. If the pixel value is 0, it represents black color. Obviously, you see which is black here. So this particular area will have the pixel value as 0. Then what about the highest value? Okay, what about 255? If 0 is black, obviously 255 will be white. So this is very important, friends. The range. For a grayscale image, the range of the pixels will be only between 0 to 255, where 0 represents black color and pixel 255 value represents white color. Then what about the rest of the values, like say 1, 2, 3, 100, 200? What about the values, the rest of the values apart from 0 and 255? The values which are between this range, they represent different shades of gray. Since it is grayscale image, see, if you have a value between 0 to 255, these values, they represent different, shades of gray color, right? So if the value is close to 255, obviously the value will be, the color will be white. And if the value is close to 0, the color will be black. Between these two colors, you'll have different shades of gray color is what the value represents. So each pixel value represents some kind of information about the color. It represents the color information. I hope it's making sense. This is more than enough. Okay, whatever we have understood with respect to grayscale image is more than enough. Now let me talk about RGB image. RGB. RGB stands for red, where R stands for red, G stands for green, B stands for blue. So RGB image is generally representing a color image. Since this is a black and white, which is a grayscale image, RGB image represents color images. Okay, so each pixel has 3 values. What are the pixel that you are going to take? So within this image, okay, you are going to represent the image in the form of pixels. So each pixel will have 3 values, not 1 value. 3 values. What are the 3 values? Green, red, green, and blue. So this is the order, right? Red, green, and blue. Making sense? So I'll just give an example that is, no, I generally give to my students. So if you have a pixel in this form, okay, so if the values are in this form, 255 comma 0 comma 0. So this represents a red pixel. This represents a red pixel because only for the red, if you see a pixel is represented with 3 numbers, right? 3 values, and 3 values are comma separated. So what is the value of red? 255. That means we have reached that maximum. What is the value for green? 0. What is the value for blue? It is also 0. So obviously this is representing a red picture. A red pixel is what it is being represented. Okay. So a standard RGB image is represented as a 3D array, friends. So probably you have to go back to the concept of arrays. Okay. So if you remember the concept of arrays, that would be very easy for us as part of CNN. Easily we can interpret the working of CNN, how CNN works. Okay. That can be understood very easily. Somehow we are going to use the concept of arrays. Yes, matrices. So we are going to represent a grayscale image in a matrix format, a 2D array, and an colored image, an RGB image will be represented as a 3D image. 3D matrix. Sorry, 3D array. Right? So where the 3 dimensions we have are height, width, and the 3. Okay. So the 3 represents the the scale RGB colors. Making sense? So the types of images, explicitly we will be using 2 types. One is grayscale and the other one is colored images. So the values in the grayscale image will be between only 0 to 255 pixels, the pixel values, and where the 0 value for the pixel represents black color and 255 value represents white color. And a grayscale image is stored as a 2D array. That's what we have discussed. It's a 2D array, which is nothing but a matrix. But a color image will be represented as a 3D array where it will have, height, width, and three color channels, all three color channel values. Okay, so that's the information that we get from this particular slide. The types of images we have also learned, right? Now, let us understand how these neural networks, especially CNN, is going to see an image, how it is going to understand an image. CNN don't see images as humans, friends. Like we humans, we visualize images, right? So in the same way, CNNs, no, they don't do the same. They process the images as matrices or arrays of numbers. Okay, so these matrices or arrays are passed through something called as filters, nothing but kernels to detect patterns. So within an image, you'll have patterns, edges, okay, the features. These features has to be recognized by using filters concept. That is what CNNs does. Okay, so how does it is going to learn everything we'll understand, but I assume no question so far. Right, let us go and understand the next topic. It's CNN. So what do you mean by convolution? Friends, this is a general question, that you can expect as part of a basic interview question. What do you mean by convolution? Any idea what exactly is convolution? Good. So if you have any kind of, understanding with respect to CNN, why don't we, share the knowledge? Do respond to my questions. No, okay. Because, if you are clear on the definition of convolution, you are done with CNN. That is where the important concept lies. What is the general meaning? What is the meaning, English meaning for convolution? Okay, no worries. Anyhow, I'll not discuss this now. Why am I not disclosing the meaning for convolution is I'll something talk about in the next class. The reason is we'll understand how CNN work, right? So CNN use the concept of convolution. Yes, so they use the concept of convolution and using the process of convolution, it gets the output using filters, the kernels, and obviously using these filters, we are going to get the output, and that is where you'll have, your features get reduced, your edges in the image, the features as part of the image will be identified. The hidden patterns within an image gets identified. No question, no worries. Anyhow, by next class, I want everyone to know what exactly is the meaning for convolution. Okay. Today, anyhow, I'll go back and talk about the architecture of a neural network. No worries. So you take a basic neural network. How many layers do you have in a neural network? What are the different types of layers do we have in a neural network? agree. Friends, why are you taking that much time? I don't know why. See, you take a neural network, a basic neural network. Okay, so we'll have input layer through which we'll pass the inputs. Then we'll have hidden layers and followed by output layer. Yes, good. We'll have input layer, hidden layers, and output layer. Yes. So in input layer, we have neurons, right? To these neurons, what we pass? We pass obviously the inputs, the features. And these features that are passed, will be multiplied with parameters like weight and bias. They'll be multiplied with parameters like weight and bias. So this will ensure that each and every neuron as part of input layer will be connected to the next layer, that is hidden layer, and this is going to be a multi-layered neural network. Okay, so under each and every hidden layer and output layer, the neuron have two parts. What are the two parts that we have in a neuron under hidden layer and output layer? What are the two parts? Friends, you should be active, and I don't want people sitting idle. No, you should respond. That's okay. If we are, wrong, no worries. So the two parts that we have in a neuron, yes, in a neuron of hidden layers and output layer are, summation function and activation function. Do we also have the same two parts in hidden layer neurons? Sorry, in the input layer neurons? No. So the parts that I'm discussing, either summation function or activation function, you will have only under hidden layer neurons and output layer neurons. Okay. But as part of input layer, there is no there is no summation function, there is no activation function. Don't get confused. Okay. So what exactly happens is when you pass the inputs, okay, when you pass your inputs, what happens is the input layer neurons take the values that we pass, and these values will be multiplied with a parameter called weights. So these weights, once after getting multiplied, they are responsible for carrying this entire input throughout the neural network. Okay, and the weights get initialized randomly. Weights initially, they get initialized randomly. So very important question. How are weights initialized in a neural network initially? Are you aware of Z distribution? Sorry, normal distribution. Okay. So weights uses the concept of normal distribution, that is nothing but Gaussian distribution. Okay. If not, Xavier initialization is used to initialize weights and bias. Okay. So randomly, once after these values got initialized, the inputs will be multiplied with 8, weights, and to this particular output, we also have bias adding to ensure the value is not getting 0, and the output will be given to, it's nothing but weighted sum. So summation function is responsible of doing all these things. It uses the formula of summation of I is equals to 1 till n. What is this I is equals to 1 till n represents? Each and every, the connection to that particular neuron. So 4 inputs, obviously 4, connections we'll have for each and every neuron present in the first hidden layer. So I'm assuming this is first, second, third. Okay, so what exactly is happening? It gets the summation function calculated, and once after getting the summation function calculated, it passes the output to activation function, and this activation function will use any of the mathematical function, right? So what is the purpose of math activation functions, friends? Why should we use activation functions? I see many of you are, joining today for the concept of CNN, but trust me, if you don't have any knowledge on neural networks, that is ANN, you can't understand CNN. That's what I'm trying to communicate from starting of this session. So just go through the videos of ANN in which we discussed how a neural network is, the working principle of a basic neural network. We understood forward propagation, backward propagation, gradient descent, okay, optimization algorithm like gradient descent. Then the types of gradient descent were also being discussed. Activation functions were also being discussed. Each and every basic topic has been discussed, right? So it's very, important, the basic, the fundamental. So how strong, if you are strong on the fundamentals, you know, you can understand any kind of concept. Anyways, I got good answers. To add non-linearity, in order to add non-linearity into the network, we use activation functions. Why again? Why should we add non-linearity? Because in the real world, majority of the data is non-linear, and moreover to activate neurons. Okay, so what exactly is happening is we use different activation functions like sigmoid. When do we use sigmoid? When do we use sigmoid? What is the formula for sigmoid function? Come on, friends. Sigmoid function is generally used in output layer. In the output layer, we use sigmoid function. And for what kind of task? For binary classification task, we use sigmoid function as an activation function in the output layer. And what is the formula? The formula is given as f of x is equals to 1 by 1 plus e to the raised power of minus x. Yes, good. This is not something new for us because we learned this sigmoid function as part of logistic regression. So what is the output of a sigmoid function? Actually, sigmoid function, it gives either 1 or 0 as output. 0 to 1. Since it is calculating probability, the output of a sigmoid function will be again same as probability 0 to 1. And since I have only two classes, binary classification, right? So two classes, either pass or fail. Person taking loan or not taking loan. Person having disease or no disease. So in these type of use cases, where we have only two classes, what we do? We use sigmoid function as an activation function in the output layer neuron. And since the output is 0 to 1, we come up with a threshold. And if the value is less than 0.5 or equals to 0.5, we'll say it as one class. And if the value is greater than 0.5, we'll keep it as the next class, class 1, class 2. That's how sigmoid function is used in a binary classification task as an activation function in output layered neuron. So friends, basics, especially activation functions, I want you guys to be very clear. The main reason is we are going to use ReLU activation function, or we'll also use the variants of ReLU. What is the formula for ReLU activation function? What is the formula for ReLU activation function? Where is ReLU activation function generally preferred? Hidden layers or output layer? What is the range of ReLU activation function? What is the formula? What are the challenges? What are the advantages? See, an interviewer can ask you n number of questions from just the activation functions topic. So, from one activation function topic, I can ask multiple questions. Think of very, very important. Why? Throughout neural networks, okay, throughout the concept of neural networks, you take any type. One concept that is generally used in all the types is activation functions. So that's okay. Even though if you have missed my previous sessions, no worries. At least go and learn activation functions today. Okay. ReLU, leaky ReLU, ELU, TANH, softmax. We have many. Not only these. ReLU is one of the widely used, commonly used activation function in hidden layered neurons. And the purpose of and the formula of ReLU is max of 0 comma x. So this ReLU is again used as an activation function in CNN. So if you are not aware of ReLU, what you are going to understand CNN? Working of CNN? Think. That is why I did not directly jump into the topic. If I start discussing the working principle of CNN, that is the end of this day. I know. Right? Making sense? ReLU uses the formula as f of x is given as max of 0 comma x. So that means the range of ReLU will be 0 to infinity. Okay. So what does this mean? Can't you get any negative value if you use ReLU activation function as activation function in hidden layer? Yes. We cannot get a negative value as output. And that is why we use ReLU in CNN to convert or to, remove that non-negative values. What is this non-negative values removing? What we'll discuss. No worries. Okay. So we'll use ReLU. Then we'll also use variants of ReLU like leaky ReLU, ELU and all. Okay. The main challenge of using ReLU is, what is the challenge of using ReLU function, friends? Dying neurons. So if I pass a value -8 to the function, if -8 is what, if I'm passing to x value, what is the output that I'll get? 0. So if the activation function, if the value if I get from here is 0, even though if I multiply with weight, again the value will be 0. What if the bias is very close to 0? So somehow your value will be very close to 0. So this is causing the neurons to die. So the first and the foremost disadvantage of using ReLU function is dying neurons. And this dying neurons will be overcome by using the variants of ReLU. Leaky ReLU, where the function is same, but instead of 0, it is 0.001, multiplied with the value of x comma x. Okay, so there this particular dying ReLU issue is solved. And we also use leaky ReLU where exponential function is being used. Right? Yes. So I'll stop here. The main reason is I want to continue the working principle of CNN, everything in the next session. Okay. I'll talk about the layers. I'll talk about the working journey. See here we have the working. What are the core components? One by one we'll talk. Okay. So the input layer is very clear for us. Okay. Depending on the image that you take, whether you take a grayscale image or a colored image, your number of inputs will change. Then followed by convolution operation. This is the place where the entire CNN, is like convolution operation takes place in convolution layer, followed by activation function, where we use ReLU. We use ReLU, okay, to convert the non-negative values to negative, zero at least. And we also use pooling layer. What does this pooling layer does? We'll understand. Okay, and we finally have fully connected layer for the regression of the classification and the output layer. We'll discuss. No worries. Okay, all these important topics we'll be discussing, and at the end, I'll also talk about the types of pooling that we have. So probably in the next session, you should be clear on the basics of neural networks. Yes. If not, somehow I cannot waste our time, right? I'll proceed. So I'll stop it here. Then I'll take your doubts. If you have any questions, yes, feel free to ask. If no questions, we'll meet in the next session. But friends, in this particular playlist, we are going to understand the complete journey of CNN, Convolutional Neural Network. At least if you are clear on neural networks, you can learn any neural network. It might be any type. Okay. So basics are very important. CNN, ANN, CNN, and RNN. 3. So Google form has been shared. You have valuable feedback, your suggestions. We'll try to improve, enhance our sessions in the coming programs. And before you leave, hit on the like button if you feel that the session went well. And we are going to learn many new things in the next session. Until then, learn, be clear on the basics. And moreover, I want you guys to know the meaning of convolution. What is the English meaning of convolution? You learn it and be ready by the next session. Right. Any questions? If you have any questions, we'll discuss. If not, we'll meet in the next session. Until then, take care, friends. Right. Have a great day. I'm signing off.